Look up at the night sky. It is full of stars, part of our galaxy, the Milky Way, a spiral galaxy. Spiral galaxies are huge collections of stars, gas, and dust, shaped like a flat disk with arms spiraling outwards. Think of a spinning pinwheel toy or water swirling down a drain. These galaxies are among the most beautiful objects in space, with their glowing arms filled with young, hot stars. The contrast of bright stars and dark dust lanes makes the spiral patterns stand out. Astronomers study these galaxies to learn about the universe. Spiral galaxies are active places where new stars are constantly being born. The gas and dust in the arms are the raw materials for star formation. Gravity pulls this material together, forming dense clumps that heat up and eventually ignite to become new stars. This process happens repeatedly, making spiral arms stellar nurseries. About 60% of all known galaxies are spirals, including our Milky Way. We live inside one of its spiral arms, so studying other spiral galaxies helps us learn about our home and our place in the cosmos. Let's explore the structure of a spiral galaxy, like a giant cosmic city with different neighborhoods. At the center is the dense, spherical central bulge, packed with older, redder stars. Many spiral galaxies have a supermassive black hole in the bulge. Surrounding the bulge is a flat, rotating disk where the spiral arms are found. The disk is rich in gas and dust, the ingredients for making new stars, making it a very active place. Young, blue stars light up the spiral arms. Our sun is located in the disk of the Milky Way, about 2/3 of the way out from the center. The spiral arms are areas where stars and gas are more concentrated, like cosmic traffic jams. As gas clouds enter an arm, they get squeezed, triggering star formation. Beyond the disk is the galactic halo, a roughly spherical region containing very old stars and dark matter. Dark matter helps hold the galaxy together with its gravity. How do these beautiful spiral galaxies come to be? It all started shortly after the Big Bang. The universe was mostly hydrogen and helium gas with tiny ripples in density. Gravity acted on these ripples, pulling in more gas and forming the seeds of future galaxies. Huge clouds of gas and dark matter began to collapse under their own gravity. If a cloud was slowly rotating, it would spin faster as it shrank, forming a rotating disk of gas. This disk was the birthplace of the galaxy's stars, with the central parts forming the bulge. Spiral galaxies can grow by merging with smaller galaxies, adding stars and gas. Sometimes two large spiral galaxies collide and merge, potentially becoming a different type of galaxy. Dark matter plays a crucial role in galaxy formation, providing the gravitational scaffolding. It helps keep the stars and gas from flying apart as the galaxy spins. Our own Milky Way galaxy is a spiral, our home in the universe. It has a central bar-shaped structure and several major spiral arms. Our sun is in a smaller spur called the Orion Arm. The Andromeda galaxy, our closest large spiral neighbor, is about 2.5 million light-years away. Andromeda is even bigger than the Milky Way, with perhaps 1 trillion stars. Andromeda and the Milky Way are moving towards each other and will collide in about 4.5 billion years. The Whirlpool Galaxy, or M51, is famous for its clear and well-defined spiral arms. It has a smaller companion galaxy, NGC 5195, at the tip of one arm, enhancing the spiral structure. The Pinwheel Galaxy, M101, is a beautiful face-on spiral, showing off its arms like a grand celestial firework. The Sombrero Galaxy, M104, seen almost edge-on, has a bright central bulge and a prominent dark lane of dust, resembling a wide-brimmed hat. Why do we care so much about spiral galaxies? They are fantastic cosmic laboratories. By studying them, we learn about star formation, as the spiral arms are active star factories. We can observe the gas and dust clouds that form stars, helping us understand how stars like our sun were born. Spiral galaxies also teach us about galaxy evolution. Looking at spirals at different distances is like looking back in time, helping us piece together the history of galaxy evolution. We can study how their structures change and how mergers affect them. These galaxies are crucial for understanding cosmic chemistry. Stars create heavier elements like carbon, oxygen, and iron, which make up planets and life. When stars die, they release these elements into the galaxy, enriching the spiral arms. Studying the composition of stars and gas in spirals tells us about this chemical enrichment. Ultimately, spiral galaxies captivate us with their sheer beauty and represent our cosmic home, the Milky Way. Studying them helps us understand our own origins and invites us to explore the universe further.